Hello, welcome to the video. In this lesson, we'll be looking at section 4.3, where we're going to be writing equations of parallel and perpendicular lines. So here at the bottom, it asks us, it says, how can you recognize lines that are parallel or perpendicular? So by definition, parallel lines are two lines on a coordinate plane that do not intersect. Perpendicular lines, they intersect at a very specific spot because they intersect at a right angle. Now, how we can recognize that is we need to put those lines into an equation. Those equations, the one that's going to help us the most is slope-intercept form. The y is equal to mx plus b. And the deciding factor if something is parallel or perpendicular is we have to be able to identify the slope of those two lines. So if we look at parallel lines and its slope, they're saying here that if two lines that are in the same plane, which in this case they're both on the same coordinate plane, and they never intersect, that makes them parallel. It says non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel. So as long as they have the same slope and they're potentially, if they're vertical lines, it just means that they're both undefined slopes. But the bottom line is, as long as they have the same slope, those particular lines are parallel. So looking at this example here, it's asking us to determine which lines are parallel. So in order to figure out which lines are parallel, we have to figure out what the slopes are for each of the lines. So I got line A, I got line B, and I got line C. So I'm going to find the slopes of them. The slope of line A is going to be, looks like it goes down 1 and to the right 1, 2, 3, 4, 5. So it looks like negative 1/5 is our slope for line A. If I look at line B, the slope for that one is going to go down 1 and it goes to the right 1, 2, 3, 4. So negative 1/4 is our slope for B. So at the moment, line A and line B are not parallel because they don't have the same slope. So now if I look at C, and I say it goes down 1 and it goes to the right 1, 2, 3, 4, 5. So line C is negative 1/5. Line A and line C have the same slope, so that means that line A and line C are parallel. In this particular example here, it says they're asking us to write an equation of a line that passes through this point, 5 comma negative 4, and is parallel to the line y is equal to 2x plus 3. So what we need to do is we need to identify two things. First thing we got to do is make sure that the given line that we want it to be parallel to, we have to make sure that it's in slope-intercept form. If it's not, we have to manipulate the equation to make it so. So as long as it's in y equals mx plus b, we're good. And in this particular instance, it is. The next thing is we have our point 5 comma negative 4. That means we have a point and we know the slope. Since the slope of the line in question is 2, that means that the slope of the line that we need to create needs to also be 2. So this is 2. We have our point, which is going to be 5 comma negative 4. Since we have a point, since we have a slope, in order to write a new equation, we are going to use point slope form first in order to uh, figure out what equation it is. So remembering this is y minus y1 is equal to m times by the quantity of x minus x1. This is my x1, this is my y1, and this is my m. So when I rewrite this, this is going to be y minus a negative 4 is equal to 2, which is the slope, times by the quantity of x minus 5. Here this will be y plus 4. And then the final step is to get it into slope-intercept form. So I got y plus 4 is equal to distributing the 2 over the x minus 5. I got 2x minus 10. And then finally, subtracting 4 to both sides, I get 2x minus 14. Okay, so that is my line that is going to be parallel to the 2x plus 3. If you want to check your answer to make sure that it is correct, what you can then do is put in this point for x and y to see if it works in this equation. So if I put negative 4 in for y and 2 times 5 minus 14, and 2 times 5 is 10, is negative 4 equal to 10 minus 14? The answer is yes. So this particular equation is valid for this particular situation. When we're dealing with perpendicular lines in the slope, it is a little bit more complex because the slopes are going to be different, but not that much different. So if it says here that two lines in the same plane that intersect to form right angles are perpendicular lines, it says non-vertical lines are perpendicular if and only if their slopes are, looks like negative reciprocals of each other, okay? Negative reciprocals of each other just simply means what you're going to do is flip the fraction, then you're going to change the sign. So if you have a slope of, let's say, 2/3, your perpendicular slope of this is going to be a negative 3/2. I flipped the fraction, which made it 3/2, and then I changed the sign. It was positive to begin with, becomes negative in the new slope. So if I had, let's say if I had a slope of negative 4, my perpendicular slope would be a positive 1/4, because remember, you have to imagine like this is negative 4 over 1, and that is how we can determine our perpendicular slope. So here it says determine which of the lines, if any, are parallel or perpendicular. So anytime you have this kind of scenario when you have it as an equation, just like when we had the parallel lines, we have to put it into slope-intercept form. So line A is already in slope-intercept form, so we're good there. B is not quite in slope-intercept form, so I gotta subtract x to both sides, and now I have 4y is equal to negative x plus 3. Divide 4 to both sides. This is going to be y is equal to negative 1/4 x plus 3/4. And then for line C, I am going to add 2x to both sides. So now I got negative 8y is equal to positive 2x plus 16 divide -8 to both sides, I get y is equal to, this gets reduced to -1/4 x minus 2. All right, so like I said, slopes that are exactly the same are parallel. So this one has a slope of 4, this one has a slope of -1/4, this one has a slope of -1/4. So the two lines that are parallel are B and C. B and C are parallel because they have the exact same slope. They're both -1/4. Now, for perpendicular ones, for the original one is 4. If I have a flip the fraction, change the sign situation, 4 and -1/4 are in fact opposite reciprocals of each other. So line A is perpendicular to both B and C. All right, this little upside down T is the symbol for perpendicular. If you're ever looking at the symbol for parallel, it kind of looks like this. It's like two vertical lines. So if you ever see that symbol, that's what that means. All right, so here, same situation, but now instead of asking that if the lines are parallel, now they're asking for a line that passes through this point, -3, 1, and now that is perpendicular to the line y is equal to 1/2 x plus 3. Same thing, make sure that this is in slope-intercept form, which it is. So now I can go about and apply my new equation into point slope form. So my point is -3, 1, but my slope of my new line, because it's perpendicular, is now going to be an opposite reciprocal to this line here. So since this line's slope is +1/2, my new slope is going to be -2 because I flipped the fraction, changed the sign. So these are the two pieces of information that I need to create my new line. All right, using point slope form to help me out, I get y minus 1 is equal to -2 times by the quantity of x minus a -3, which is actually x plus 3. And then once we get here, I get y minus 1 is equal to, I distribute here and here, so that's -2x minus 6. Add 1 to both sides. I get y is equal to -2x minus 5. And again, you can check your answer. So 1, let's see if that is going to be equal to -2 times it by -3 minus 5. So this is just using that point to see if it works out. So 1 is equal to +6 minus 5. 1 equals 1. The answer is yes. This is our equation that is both perpendicular to this line and goes through the point -3, 1. All right, so here it says the position of a helicopter search and rescue crew is shown in the graph. The shortest path to the shore is the one that is perpendicular to the shoreline. They're asking us to write an equation that represents that path. So what you can do is, first thing that I would do is try to find points that go through like integers. So like if you notice here, this one goes through, it looks like 12 comma 1. That goes through the red line that's supposedly going to be perpendicular to the shoreline. And looking at the green one, looks like this one is in the, and that looks like it's at 10 comma -3. And then looks like this one is as well, and looks like 4 comma 1. All right, so what this does is this is just more of a validation to show, because we have a graph, that the 2 points that I'm going to find the slope My hopes is that those two points are going to show that those two slopes are perpendicular. So looking at the green line slope, it looks like it's going to go down 1, 2, 3, 4. So it's down 4, so -4. And then it's going to go to the right 1, 2, 3, 4, 5, 6. So my slope of the green line is a -2/3. So for the red line slope, it needs to be a +3/2 in order for it to be perpendicular. So let's hope and see what this does. So looking at this point here at 12:1, looks like it goes up 1, 2, 3. So we got 3, and then to the right 1, 2. All right. Are oops, wrote it wrong. Are these two opposite reciprocals? The answer is yes, because if I were to flip the fraction and change the sign, they are in fact opposite reciprocals. So I found the slope of the red line. All right, they also gave us a point. So we now have a slope, we now have a point. Basically, we're just going to do the exact same thing that we did in the previous example. We're going to use point slope form, so it's going to be y minus 4 is equal to the slope, which is 3/2, times it by the quantity of x minus 14. So we do some distributing here with the 3/2. So I got y minus 4 is equal to 3/2 x minus, so I got 3/2 times it by the -14, so that's minus 21. And then I add 4 to both sides. So now my equation is going to be y equals positive 3/2 x minus 17. And that is being able to write equations of parallel and perpendicular lines. Hope this helps. Till next time.